Team, we are ready for piecewise functions. So let's focus first on what a piecewise function is. It is two or more functions that are defined over different intervals of the domain. The first example of a piecewise function, we have f of x, where the first piece is a linear equation of 3 minus x, and that's only defined for all the x's less than or equal to 2. And the second piece is a quadratic, which is defined as x squared for all x's that are larger than 2. Well, the first thing they want us to do is graph it. So if you want to, you can consider this, part A and part B of the piecewise function. If we're focusing first on part A, that's the y equals, and you can put it in mx plus b format if you want, negative x plus 3. Notice this is only defined at 2 and numbers less than 2. So it'd be defined at 2, 1, 0, negative 1, and so forth. So we definitely want to graph it at 2 so we know where that line stops. If we plugged in 2 for our x, that would give us a negative 2 plus 3. So our y value would be 1. We could plug in 1 for our x, and that would give us a 2. And even right there, we can graph those. We've got x at 2, y is 1, x is 1, y is 2. Also, if you put it in mx plus b format, we can take a look at the intercept, the y-intercept, which is up here at 3. So instead of drawing the line all the way through it, though, we know that it's defined only down to where the x value is 2. So we have to stop there, but the 2 is included, so we can color in that point. For our second equation, we have y equals x squared. This is only true for x's that are larger than 2. If we were to create a table for it, however, we would still want to start at 2 and then go up 2, 3, 4, 5. The reason is, even though this 2 is not defined by the x squared, a 2.1 or 2.0001 is. So we need to have at least an open circle, whatever value it would be if x equaled 2. So 2 squared would give us a 4, 3 squared would give us a 9. So 2 squared would give us a 4. 3 squared would give us a 9. So 6, 7, 8, 9 would be up here somewhere. So that would give us a quadratic that looks something like that. And that is a piecewise function, 2 different pieces depending on what the input value is. In part B, they're asking us to find f of negative 4, f of 2, and f of 3. So we have to look at the domain for each piece. So for the first one, we're looking at x is a negative 4. That negative 4 is in fact less than or equal to 2. So we're going to use the first part of that piecewise function of the 3 minus x. We're going to plug in a negative 4 for that x. So we get a y value of 7. So that means when x is negative 4, our y value is 7. For the second function, they're telling us that x is going to equal 2. Well, that only satisfies that first domain of less than or equal to 2. So we're still going to use that first piece of y equals 3 minus x. Plug in that 2. And we get y equals a value of 1. So the point 2, 1 is in fact on our function. The very last value that they give us, f of 3, means our x equals 3. But again, as we look up here for our domain, that 3 satisfies the second piece where it's larger than 2. So we're going to use the piece where x is squared. Plug in our x of 3, and we get y equals 9. So we have the point 3, 9. Then they want us to state the domain. Well, notice for both pieces, You have x less than or equal to 2 and x greater than 2. If you were to graph that on a number line, that it would include all real numbers. So our domain is everybody from negative infinity to infinity.